Welcome to 1 Hours of Unsolved Universe Secrets. Tonight, we invite you to let these mysteries guide you into a state of wonder, rest, and deep relaxation. As the cosmos unfolds its enigmas, allow your mind to wander, to drift, and to explore the infinite questions that lie beyond our understanding. This is a journey through the unknown, a gentle exploration of the universe's greatest mysteries, designed to soothe your thoughts and calm your spirit. As you listen, you might find yourself drawn into the vastness of space, where stars whisper secrets and galaxies hold untold stories. Each mystery we explore will unravel slowly, giving your mind the space to reflect, to imagine, and to rest. There's no need to solve these puzzles tonight. Instead, let them carry you away, like a gentle current in the cosmic ocean. To make the most of this experience, we suggest finding a quiet, comfortable space. Dim the lights or perhaps close your eyes. Let the world around you fade into the background as the universe takes center stage. If you're lying down, allow your body to sink into the surface beneath you, releasing any tension with each breath. This is your time to relax, to wonder, and to simply be. The mysteries we'll explore tonight are as vast as the cosmos itself. We'll ponder the silence of the universe and the question of whether we're truly alone. We'll delve into the invisible web of dark matter, holding galaxies together in an unseen embrace. We'll contemplate the end of time, the shape of reality, and the echoes of the Big Bang that still resonate across the cosmos. Each segment is designed to spark curiosity while inviting you to let go, to rest, and to dream. As we begin, let the ambient sounds of the universe surround you. Imagine yourself floating in the vastness of space, weightless and free. The stars above you shimmer faintly, their light traveling millions of years to reach your eyes. The silence of the cosmos is not empty, but full of possibility. A canvas waiting to be painted with your thoughts, your dreams, and your imagination. This journey is not just about the mysteries of the universe, but also about the mysteries within you. As we explore the cosmos, you might find yourself reflecting on your own place in the grand tapestry of existence. What does it mean to be a part of something so vast, so ancient, and so mysterious? There are no answers tonight. Only questions, and the gentle invitation to let them linger in your mind. So, as we begin, take a deep breath in and out. Let your shoulders relax, your jaw unclench, and your mind settle. The universe is vast, but in this moment, you are exactly where you need to be. Let the mysteries unfold at their own pace, and allow yourself to drift along with them. In a moment, we'll dive into our first mystery, the Fermi Paradox. Where is everyone? In a universe so vast, so full of stars and planets, why does it feel so silent? But before we begin, let the ambient sounds of the cosmos wash over you. Feel the gentle hum of distant stars, the soft echoes of galaxies far away. Let these sounds carry you deeper into relaxation as we prepare to explore the unknown together. Let us begin our journey with one of the most profound questions humanity has ever asked. Where is everyone? In a universe so vast, so ancient, and so full of stars, why does it feel so silent? This is the Fermi Paradox, a mystery that has puzzled scientists, philosophers, and dreamers for decades. Imagine for a moment the sheer scale of the cosmos. Our galaxy, the Milky Way, is home to over 100 billion stars. Many of these stars have planets orbiting them, and some of those planets may be Earth-like with the right conditions for life. And yet, as we gaze into the night sky, we hear nothing. No signals, no messages, no signs of intelligent life. The universe, it seems, is eerily quiet. This silence is the heart of the Fermi Paradox. named after the physicist Enrico Fermi, who famously asked, "Where is everyone?" The paradox challenges our assumptions about the universe. If life is common, if intelligence evolves naturally, and if civilizations have had billions of years to arise and spread across the galaxy, why haven't we found them? Why haven't they found us? Let's explore some of the theories that attempt to answer this question. As we do, allow yourself to drift into the mystery. Imagine the cosmos as a vast, silent ocean, its depths hiding secrets we can only begin to fathom. Let the theories wash over you, not as definitive answers, but as whispers from the unknown. Theory 1: the Great Filter. One possibility is that there is something, a great filter, that prevents life from reaching a stage where it can communicate across the stars. This filter could be a rare and insurmountable barrier, a point in the evolution of life where almost all civilizations fail. Perhaps it's the emergence of life itself. Maybe the spark that turns chemistry into biology is so unlikely that Earth is a cosmic fluke. Or perhaps the filter lies ahead of us, in the challenges of surviving as a technological civilization. Climate change, nuclear war, or other self-inflicted catastrophes could be the filter that silences civilizations before they can reach the stars. As you ponder this idea, let your mind wander. Imagine civilizations rising and falling, their light flickering out before it can be seen. The universe, in this view, is a graveyard of possibilities, a silent testament to the fragility of life. But there's a strange comfort in this thought, too. If the great filter is behind us, it means we've overcome something extraordinary. If it's ahead of us, well, perhaps we can find a way to survive. Theory 2: the zoo hypothesis. Another theory suggests that we are not alone, we are simply being left alone. This is the zoo hypothesis. Imagine that advanced civilizations exist, but they have chosen not to reveal themselves to us. Perhaps they are observing us from a distance, like scientists studying animals in a zoo. Or perhaps they have decided that contact would be too dangerous, too disruptive for a young civilization like ours. In this view, the silence of the cosmos is not a sign of emptiness, but of restraint. The universe is full of life, but it remains hidden, waiting for the right moment to make itself known. As you consider this idea, let it lull you into a sense of calm. Imagine the stars above as windows, behind which countless eyes might be watching, waiting, and wondering about us, just as we wonder about them. Theory 3: the simulation argument. Finally, there is the simulation argument. What if the universe we see is not the true universe, but a simulation created by an advanced civilization? In this scenario, the silence of the cosmos could be a design choice. Perhaps the creators of the simulation have limited its scope, or perhaps they are the only other beings that exist. This theory blurs the line between reality and illusion, inviting us to question the very nature of existence. As you think about this possibility, let your mind drift. Imagine the stars above as pixels on a screen, the galaxies as lines of code in a vast cosmic program. The silence of the universe, in this view, is not a mystery to be solved, but a feature of the simulation itself. It's a strange and unsettling thought, but also a strangely comforting one. If we are living in a simulation, it means that somewhere, in some reality, intelligence has thrived long enough to create worlds like ours. Soothing spin. As we ponder these theories, let the silence of the cosmos wash over you. Imagine it not as emptiness, but as a canvas, waiting to be filled with your thoughts, your dreams, and your imagination. The Fermi Paradox is not just a question about aliens, it's a question about us. Who are we in a universe so vast and so silent? What does our existence mean in the grand scheme of things? There are no answers tonight, only questions. And that's okay. Sometimes, the beauty of a mystery lies not in solving it, but in letting it linger, like a distant star whose light has traveled millions of years to reach your eyes. So, as we prepare to move into the next segment, let the silence of the cosmos lull you into a state of wonder and rest. Interlude prep. As we ponder this silence, let your thoughts drift, like stardust carried on the cosmic wind. In a moment, we'll explore another mystery of the universe, dark matter, the invisible web that holds galaxies together. But for now, let the ambient sounds of the cosmos surround you. Feel the gentle hum of distant stars, the soft whispers of galaxies far away. Let these sounds carry you deeper into relaxation as we prepare to continue our journey. Now, let us turn our attention to one of the most elusive and mysterious substances in the universe, dark matter. Unlike the stars, planets, and galaxies we can see, dark matter is invisible. It does not emit light, nor does it reflect it. And yet, it makes up about 27% of the universe's total mass. It is everywhere, woven into the fabric of space itself, holding galaxies together in an unseen web. Imagine, for a moment, a spider's silk, delicate yet strong, stretching across the night. Now, picture that web on a cosmic scale, connecting galaxies, clusters, and superclusters. This is the role of dark matter, a silent, invisible force that shapes the universe as we know it. Without it, galaxies would fly apart, their stars scattering into the void. And yet, despite its importance, we know almost nothing about what dark matter truly is. Let's explore this mystery together. As we do, allow yourself to drift into the unknown. Picture the universe as a vast, dark ocean, its depths hiding secrets we can only begin to fathom. Let the questions wash over you, not as problems to be solved, but as whispers from the cosmos, inviting you to wonder and dream. What is dark matter? Dark matter is not like the matter we encounter in our everyday lives. It does not consist of atoms, nor does it interact with light or other forms of electromagnetic radiation. We cannot see it, touch it, or detect it directly. And yet, we know it exists because of its gravitational effects. Galaxies rotate faster than they should, given the amount of visible matter they contain. Clusters of galaxies bend light in ways that cannot be explained by the matter we can see. These phenomena point to the presence of something unseen, something massive, something mysterious. As you ponder this invisible substance, let your mind wander. Imagine the universe as a grand tapestry, woven with threads of light and shadow. The stars and galaxies are the bright threads, glowing with the light of billions of suns. But the dark threads, the dark matter, are just as important, holding the tapestry together, giving it shape and structure. Feel the quiet pull of this unseen web as it stretches across the cosmos, connecting everything in its grasp. Why can't we detect it directly? One of the greatest mysteries of dark matter is why we can't detect it directly. If it makes up such a significant portion of the universe, Why does it remain so elusive? Scientists have built elaborate experiments to search for dark matter particles deep underground, where they are shielded from cosmic rays and other interference. And yet, so far, these experiments have come up empty. It's as if dark matter is a ghost, slipping through our fingers no matter how tightly we try to grasp it. There are many theories about why this might be. Perhaps dark matter particles interact so weakly with ordinary matter that our instruments simply cannot detect them. Or perhaps dark matter is not made of particles at all, but something entirely different, something we have yet to imagine. As you consider these possibilities, let the mystery lull you into a state of calm. Imagine the universe as a puzzle, its pieces hidden in the shadows, waiting to be discovered. What is dark matter made of? If we cannot detect dark matter directly, how can we hope to understand what it is made of? This is one of the most profound questions in modern science. Some theories suggest that dark matter consists of particles called WIMPs, weakly interacting massive particles. These hypothetical particles would be heavy and slow-moving, rarely interacting with ordinary matter. Other theories propose that dark matter is made of axions, ultralight particles that could flow through the universe like a cosmic breeze. And then there are the more exotic ideas. Some scientists have suggested that dark matter could be made of primordial black holes, formed in the early universe. Others have proposed that dark matter is not matter at all, but a manifestation of gravity itself, a shadowy force that operates on scales we cannot yet comprehend. As you think about these possibilities, let your mind drift. Imagine the universe as a symphony, with dark matter as its silent, unseen conductor, guiding the movements of stars and galaxies with an invisible hand. Calming angle. As we ponder the mysteries of dark matter, let the unseen web of the cosmos surround you. Picture it stretching across the universe, connecting galaxies, clusters, and superclusters in a vast, intricate network. Feel its quiet pull, gentle yet unyielding, holding the universe together in a delicate balance. Dark matter may be invisible, but its presence is felt in every corner of the cosmos, in every star, in every galaxy, in every atom. There is a strange comfort in this thought. Even in the vastness of space, even in the depths of the unknown, there is order. There is structure. The universe is not a chaotic void, but a carefully woven tapestry, its threads of light and shadow intertwined in a dance that has lasted billions of years. And we, tiny though we may be, are a part of that dance. Interlude prep. As we ponder the invisible web of dark matter, let your thoughts drift, like stardust carried on the cosmic wind. In a moment, we'll explore another mystery of the universe, the heat-death of the universe, the ultimate fate of all things. But for now, let the ambient sounds of the cosmos surround you. Feel the gentle hum of distant stars, the soft whispers of galaxies far away. Let these sounds carry you deeper into relaxation as we prepare to continue our journey. Now, let us turn our gaze to the far future, a future so distant that it stretches the limits of imagination. We are going to explore the ultimate fate of the universe, a concept known as the heat death. It is a quiet, gradual end, not with a bang, but with a whisper, a fading, a cooling, a slow descent into entropy where the universe reaches its final equilibrium. Imagine, for a moment, the universe as a vast cosmic clock, ticking away the seconds, the years, the eons. For billions of years, it has been expanding, growing, evolving. Stars have been born, galaxies have formed, and life has emerged. But like all things, the universe too has an end. And that end is not a fiery collapse, but a gentle fading, a cooling into darkness. Let's explore this concept together. As we do, allow yourself to drift into the vastness of time. Picture the universe as an ocean, its waves slowly calming, its currents gradually stilling. Let the questions wash over you, not as fears, but as whispers from the cosmos, inviting you to reflect and dream. What is the heat death of the universe? The heat death of the universe is a prediction based on the second law of thermodynamics, which states that entropy, a measure of disorder, always increases over time. In simple terms, the universe is slowly running out of usable energy. Stars will eventually burn out, galaxies will drift apart, and all matter will decay into its simplest forms. The universe will become a cold, dark, and lifeless expanse, where no energy is left to sustain motion, light, or life. This process is not sudden or violent. It is gradual, taking place over trillions upon trillions of years. The universe will continue to expand, its galaxies growing farther and farther apart, until they are isolated islands in an endless void. The last stars will flicker out, and the last black holes will evaporate, leaving behind only a faint, uniform glow of radiation, the dying embers of a once vibrant cosmos. As you ponder this distant future, let your mind wander. Imagine the universe as an old, weary traveler, slowly making its way to the end of an unimaginably long journey. There is a strange beauty in this thought, a quiet dignity in the idea of a universe that has lived its life and is now ready to rest. Philosophical angle: what does this mean for meaning, for legacy? The heat death of the universe raises profound questions about meaning and legacy. If the universe is destined to fade into darkness, what does that mean for us? For our lives, our achievements, our memories? In the face of such vastness, such inevitability, it's easy to feel small, insignificant. And yet, there is another way to look at it. Consider this: the universe has existed for nearly 14 billion years, and in all that time, it has produced beings capable of contemplating its fate. We are the universe's way of understanding itself, of reflecting on its own existence. In that sense, we are not separate from the cosmos, we are a part of it, a fleeting but meaningful expression of its complexity and beauty. As you reflect on this idea, let it lull you into a state of calm. Imagine the universe as a story, written in the language of stars and galaxies. We are but a single sentence in that story, a brief moment in an epic that spans eons. And yet, that moment is ours. It is real, it is meaningful, and it is beautiful. Soothing frame: even in this vast end, there's a strange peace. The heat death of the universe is not a tragedy. It is not an end to be feared, but a natural conclusion to a story that has been unfolding since the Big Bang. In its own way, it is a kind of peace, a return to equilibrium, a final stillness after eons of motion and change. As you think about this, let the idea wash over you. Picture the universe as a vast, dark ocean, its waves finally calming, its surface smooth and still. There is a strange comfort in this image, a sense of closure, of completeness. The universe has lived its life and now it rests, And in that rest there is beauty. The stars may fade, the galaxies may drift apart, but the story of the universe, our story, will always have been real. The moments of light, of life, of love, they will always have mattered. In the face of the heat death, we can find not despair, but peace, a quiet acceptance of the natural order of things. Interlude prep. As we ponder the heat death of the universe, let your thoughts drift, like stardust carried on the cosmic wind. In a moment, we'll explore another mystery of the universe, the Big Bang's missing pieces, the questions that remain about the beginning of all things. But for now, let the ambient sounds of the cosmos surround you. Feel the gentle rhythm of the universe's heartbeat, the soft whispers of distant waves. Let these sounds carry you deeper into relaxation as we prepare to continue our journey back to the very beginning, to the moment that set everything in motion. The Big Bang. It is the story of how our universe began, a cosmic explosion that gave birth to stars, galaxies, and ultimately, us. And yet, for all we know about the Big Bang, there are still profound questions that remain unanswered. What triggered it? What came before? And what, if anything, lies beyond the edges of our understanding? These are the missing pieces of the Big Bang, the mysteries that linger at the boundaries of science and imagination. As we explore them, allow yourself to drift into the unknown. Picture the universe as a vast, dark canvas, its first brushstrokes still hidden in shadow. Let the questions wash over you, not as problems to be solved, but as whispers from the cosmos, inviting you to wonder and dream. What triggered the Big Bang? The Big Bang is often described as the moment when the universe began, a singularity of infinite density and temperature that expanded into the cosmos we know today. But what caused this singularity? What set the universe in motion? This is one of the greatest mysteries in science. We can trace the history of the universe back to a fraction of a second after the Big Bang, but the moment of the Big Bang itself and what came before remains shrouded in mystery. Some scientists suggest that the Big Bang was triggered by a quantum fluctuation, a random event in the fabric of reality that caused a tiny patch of space to expand rapidly. Others propose that it was the result of a collision between two universes in a higher dimensional space. And then there are those who suggest that the Big Bang was not a beginning at all, but a transition, a moment when a previous universe collapsed and gave birth to our own. As you ponder these ideas, let your mind wander. Imagine the universe as a seed, bursting forth from the soil of nothingness, its potential waiting to unfold. The Big Bang is not just a moment in time. It is the moment, the spark that ignited the cosmos. And yet, its origins remain a mystery, a question mark at the heart of existence. What came before the Big Bang? If the Big Bang was the beginning of our universe, what came before it? This is a question that challenges our very understanding of time. In our everyday lives, we think of time as a straight line, moving from past to future. But at the moment of the Big Bang, time itself may have begun. So what does it mean to ask what came before? Some theories suggest that there was no before. Time as we know it did not exist. The Big Bang was not just the beginning of the universe. It was the beginning of time itself. In this view, the question of what came before is like asking what is north of the North Pole. It is a question that has no meaning, because the concept of before simply did not exist. Other theories propose that time is cyclical, that the universe goes through endless cycles of expansion and contraction. In this view, the Big Bang was not the beginning but a transition, a moment when a previous universe collapsed and a new one was born. As you consider this idea, let it lull you into a state of calm. Imagine the universe as a great wheel, turning endlessly through time, its cycles echoing across the cosmos. Theories, quantum fluctuations, and cyclic universes. Let's delve a little deeper into these theories. The idea of quantum fluctuations suggests that the Big Bang was the result of a random event in the quantum vacuum, a sea of potential energy that exists even in empty space. In this view, the universe is not the product of a grand design, but a cosmic accident, a fluctuation that grew into something extraordinary. The idea of cyclic universes, on the other hand, suggests that the Big Bang was not a unique event, but part of an endless cycle. In this view, the universe expands, cools, and eventually collapses, only to begin again in a new Big Bang. This cycle repeats endlessly, with each universe giving birth to the next. As you think about these possibilities, let your mind drift. Imagine the universe as a phoenix, rising from its own ashes, its cycles of birth and death stretching across eternity. Calming spin. Before time, there was nothing, or was there? As we ponder the missing pieces of the Big Bang, let the mystery wash over you. Picture the moment before the Big Bang. A void, a nothingness, a silence so profound that it defies imagination. And yet, in that void, there was potential. The potential for stars, for galaxies, for life. The potential for you. In this moment, let yourself drift into that void. Feel its stillness, its emptiness, its infinite possibility. Before time, there was nothing, or was there? Perhaps there was something, a spark, a whisper, a question waiting to be asked. And from that question, the universe was born. Interlude prep. As we ponder the missing pieces of the Big Bang, let your thoughts drift, like raindrops falling into an endless ocean. In a moment, we'll explore another mystery of the universe, the multiverse, the idea that our universe may be just one of many. But for now, let the ambient sounds of the cosmos surround you. Feel the gentle rhythm of the rain, the soft hum of static. Let these sounds carry you deeper into relaxation as we prepare to continue our journey. Now, let us venture beyond the boundaries of our universe, into the realm of the multiverse. The idea that our universe might not be the only one, that there could be countless others, each with its own laws, its own stars, its own stories. This is the concept of the multiverse, a theory that stretches the limits of our imagination and challenges our understanding of reality. Imagine, for a moment, that our universe is just one page in an infinite book. Each page tells a different story with different characters, different rules, and different outcomes. Somewhere in another universe, the laws of physics might be slightly different. Stars might burn brighter or dimmer. Life might take forms we cannot imagine. And history might have unfolded in ways we can scarcely dream of. This is the multiverse, a tapestry of realities, woven together in ways we are only beginning to understand. As we explore this idea, allow yourself to drift into the unknown. Picture the multiverse as a vast, shimmering ocean, its waves lapping against the shores of countless worlds. Let the questions wash over you, not as problems to be solved, but as whispers from the cosmos, inviting you to wonder and dream. Introducing multiverse theories. The concept of the multiverse is not a single idea, but a collection of theories, each offering a different perspective on the nature of reality. One of the most well-known is the idea of infinite realities, where every possible outcome of every possible event exists in its own universe. In this view, every choice you've ever made and every choice you didn't make has played out in some other universe. Somewhere, another version of you is living a life that is almost the same as yours, but just slightly different. Perhaps in that universe you took a different path, made a different decision, or dreamed a different dream. And somewhere else, another version of you is living a life that is entirely unrecognizable, shaped by a universe with entirely different rules. Another theory suggests that our universe is just one of many bubble universes, each existing in its own pocket of space-time. These bubbles might have formed during the early moments of the Big Bang, when the fabric of reality was still unstable. In this view, the multiverse is like a cosmic foam, with each bubble representing a separate universe, each with its own unique properties. Some bubbles might be vast and expansive, filled with galaxies and stars, while others might be small and dense, collapsing in on themselves almost immediately. And still others might be so strange, so alien, that we cannot even begin to imagine what they might contain. Yet another theory proposes that the multiverse is not just a collection of separate universes, but a single, interconnected reality. In this view, our universe is just one layer of a much larger structure, like a sheet of paper in a stack of countless others. These layers might be separated by dimensions we cannot perceive, dimensions that exist beyond the three we know. In this multiverse, the boundaries between realities are not fixed, but fluid, allowing for the possibility of interaction, of overlap, of connection. As you ponder these ideas, let your mind wander. Imagine the multiverse as a vast, shimmering tapestry, its threads woven from the fabric of countless realities. Each thread is a universe, each not a moment in time, and together they form a pattern that is as beautiful as it is mysterious. Unanswered questions. Can we ever know? What's beyond our universe? The multiverse raises profound questions about the nature of reality. If there are other universes, can we ever know about them? Can we ever visit them or communicate with them? Or are they forever beyond our reach, hidden behind the veil of our own universe? These questions are not just scientific, they are philosophical. They challenge us to think about what it means to exist, to be real. If there are other universes, does that make our universe less special? Or does it make the multiverse as a whole more wondrous, more complex, more beautiful? Consider this. If the multiverse is real, then every possible version of reality exists somewhere. Every dream, every nightmare, every hope, every fear, they all exist in some form, in some universe. In one universe, humanity has achieved utopia, a world of peace and prosperity. In another, the stars have gone dark, and the universe is a cold, empty void. And in yet another, life never arose at all, and the universe is silent, its potential unfulfilled. As you consider these possibilities, let them lull you into a state of calm. Imagine the multiverse as a vast, dark forest, its trees stretching into infinity. Each tree is a universe, each branch a possibility, and together they form a landscape that is as mysterious as it is endless. The philosophical implications of the multiverse. The multiverse is not just a scientific theory. It is a mirror, reflecting our deepest questions about existence, meaning, and identity. If there are other versions of us, living other lives in other universes, what does that mean for who we are? Are we defined by our choices, or are we just one thread in a vast, interconnected tapestry? Some philosophers argue that the multiverse diminishes our significance, reducing us to just one of countless possibilities. Others see it as a source of comfort, a reminder that no matter what happens in this universe, somewhere, in some other reality, things might be different. And still others see it as a call to action, a challenge to make the most of the life we have, knowing that it is unique, even in a multiverse of infinite possibilities. As you reflect on these ideas, let them wash over you. Imagine the multiverse as a symphony, its notes echoing across the cosmos. Each note is a universe, each chord a moment in time, and together they form a melody that is as beautiful as it is infinite. Soothing angle. Somewhere, another you might be listening. As we ponder the multiverse, let the mystery wash over you. Picture the countless realities that might exist, each with its own version of you. Somewhere, another you might be listening to these words in a universe almost identical to this one. Or perhaps, in another universe, you are living a life that is completely different, a life you can scarcely imagine. Let that thought fade, like a dream upon waking. The multiverse is not just a scientific theory. It is a canvas, waiting to be painted with your thoughts, your dreams, your imagination. Whether or not other universes exist, the idea of the multiverse invites us to wonder, to dream, and to explore the infinite possibilities of existence. Interlude prep. As we ponder the multiverse, let your thoughts drift, like cosmic winds carrying stardust across the void. In a moment, we'll explore another mystery of the universe, black holes and the paradox of information loss. But for now, let the ambient sounds of the cosmos surround you. Feel the gentle chimes, the soft whispers of cosmic winds. Let these sounds carry you deeper into relaxation as we prepare to continue our journey. Now, let us turn our gaze to one of the most enigmatic and awe-inspiring phenomena in the universe: black holes. These cosmic giants, born from the collapse of massive stars, are regions of space where gravity is so intense that nothing, not even light, can escape. But black holes are more than just cosmic vacuum cleaners. They are also the stage for one of the greatest paradoxes in modern physics: the mystery of information loss. Imagine, for a moment, standing at the edge of a black hole. The pull of its gravity is irresistible, a force so powerful that it warps space and time itself. If you were to fall into a black hole, what would happen to you? According to classical physics, you would be stretched and compressed, torn apart by the immense tidal forces, until you reached the singularity at the center, a point of infinite density where the laws of physics as we know them break down. But what happens to the information that makes up you? Your memories, your thoughts, your very essence? Does it vanish forever, lost in the depths of the black hole? Or is it somehow preserved, hidden in a way we cannot yet understand? This is the paradox of information loss in black holes, a puzzle that has puzzled scientists for decades. As we explore this mystery, allow yourself to drift into the unknown. Picture the black hole as a cosmic abyss, its depths hiding secrets we can only begin to fathom. Let the questions wash over you, not as problems to be solved, but as whispers from the cosmos, inviting you to wonder and dream. The paradox of information loss. In the 1970s, physicist Stephen Hawking made a startling discovery. Black holes are not completely black. They emit radiation, now known as Hawking radiation, which causes them to slowly lose mass and eventually evaporate. This discovery was groundbreaking, but it also raised a profound question. What happens to the information contained in the matter that falls into a black hole? According to the laws of quantum mechanics, information cannot be destroyed. It can be scrambled, transformed, or hidden, but it must always be preserved. Yet, if a black hole evaporates completely, leaving behind only Hawking radiation, it seems that the information about the matter that fell into it is lost forever. This contradiction between quantum mechanics and general relativity is known as the information paradox, and it remains one of the greatest unsolved problems in physics. As you ponder this paradox, let your mind wander. Imagine the black hole as a cosmic shredder, tearing apart the fabric of reality and scattering its pieces into the void. But where do those pieces go? Are they lost forever, or are they somehow encoded in the Hawking radiation, waiting to be deciphered? Theories, Hawking radiation and the holographic principle. Let's delve deeper into the theories that attempt to resolve the information paradox. The first is Hawking radiation itself. When Hawking first proposed that black holes emit radiation, he suggested that this radiation was random, carrying no information about the matter that had fallen into the black hole. But later, physicists began to question this idea. Could the radiation somehow encode the information, preserving it even as the black hole evaporates? One possibility is that the information is encoded in the subtle correlations between particles of Hawking radiation. Like a jigsaw puzzle, the information might be scattered across the radiation, waiting to be pieced together. But how this happens and whether it can fully resolve the paradox remains a mystery. Another theory is the holographic principle, which suggests that all the information contained within a black hole is encoded on its surface or event horizon. In this view, the black hole is like a hologram with a two-dimensional surface encoding all the information about the three-dimensional space within. This idea is deeply counterintuitive, but it offers a tantalizing possibility. That information is not lost, but transformed, encoded in a way we do not yet fully understand. As you consider these theories, let them lull you into a state of calm. Imagine the black hole as a cosmic puzzle, its pieces scattered across the universe, waiting to be discovered. The information paradox is not just a scientific problem. It is a gateway to new ways of thinking about reality, about space, about time. Calming frame. Imagine falling into a black hole. As we ponder the mystery of information loss, let the black hole's pull wash over you. Imagine falling into its depths, not with fear, but with curiosity. Picture the event horizon, the point of no return, as a threshold between the known and the unknown. Beyond it lies the singularity, a place where the rules of reality as we know them no longer apply. What happens there? Does the information that makes up you vanish, lost in the infinite density of the singularity? Or is it preserved, encoded in some way we cannot yet comprehend? The answer, for now, remains hidden, a secret held by the cosmos. Let the mystery pull you under, like a gentle current in a vast, dark ocean. The black hole is not just a destroyer, it is a teacher, challenging us to rethink our understanding of the universe. And in that challenge, there is beauty, a reminder that the cosmos is full of wonders we have yet to discover. Interlude Prep. As we ponder the mystery of black holes, let your thoughts drift, like whispers carried on the cosmic wind. In a moment, we'll explore another mystery of the universe, the fine-tuning problem, the delicate balance that makes life possible. But for now, let the ambient sounds of the cosmos surround you. Feel the distant thunder, the faint whispers of the void. Let these sounds carry you deeper into relaxation as we prepare to continue our journey. Let's turn our attention to one of the most profound and puzzling questions in science and philosophy, the fine-tuning problem. The universe, as we know it, is governed by a set of constants, numbers that define the strength of gravity, the speed of light, the mass of particles, and more. These constants are finely tuned to an extraordinary degree. If they were even slightly different, life as we know it would not exist. Stars would not shine, atoms would not form, and the universe would be a cold, empty void. This delicate balance raises a profound question. Why is the universe so perfectly tuned for life? Is it the result of chance, of design, or of something else entirely? As we explore this mystery, allow yourself to drift into the unknown. Picture the universe as a grand symphony, its notes perfectly arranged to create a harmony that allows life to flourish. Let the questions wash over you, not as problems to be solved, but as whispers from the cosmos, inviting you to wonder and dream. The fine-tuning of the universe. The fine-tuning of the universe is evident in many of its fundamental constants. Take, for example, the strength of gravity. If gravity were even slightly stronger, stars would burn out too quickly, leaving no time for life to evolve. If it were slightly weaker, stars might never form at all. Similarly, the mass of the proton and neutron are finely balanced to allow the formation of stable atoms. If the proton were just a little heavier, hydrogen, the most abundant element in the universe, would not exist, and neither would water nor life as we know it. Even the expansion rate of the universe is finely tuned. If the universe had expanded too quickly after the Big Bang, matter would have spread out too thinly for galaxies to form. If it had expanded too slowly, the universe would have collapsed back in on itself before life could arise. These are just a few examples of the many constants that must be precisely balanced for life to exist. As you ponder this delicate balance, let your mind wander. Imagine the universe as a cosmic clock, its gears perfectly aligned to keep time. Each constant is a gear, each law of physics a spring, and together they create a mechanism of breathtaking precision. The fine-tuning of the universe is not just a scientific fact. It is a source of wonder, a reminder of the extraordinary complexity and beauty of existence. Theories, design, chance, or infinite universes. The fine-tuning of the universe has led to many theories about why it exists. One possibility is that the universe was designed by an intelligent creator who set the constants to allow life to flourish. This idea, often associated with the argument from design, suggests that the fine-tuning of the universe is evidence of purpose, of intention, of a mind behind the cosmos. Another possibility is that the fine-tuning is the result of chance. In this view, the universe is a cosmic lottery, and we are the lucky winners. The constants could have taken any value, but by sheer luck, they fell within the narrow range that allows life to exist. This idea is often associated with the anthropic principle, which states that we observe the universe to be fine-tuned because we exist to observe it. If the universe were not fine-tuned, we would not be here to ask the question. Yet another theory is that our universe is just one of many in a multiverse. In this view, each universe has its own set of constants, and we happen to live in one where the constants are just right for life. The multiverse theory suggests that fine-tuning is not a mystery, but a statistical inevitability. In an infinite multiverse, every possible combination of constants exists somewhere, and we simply find ourselves in a universe where life is possible. As you consider these theories, let them lull you into a state of calm. Imagine the universe as a vast, shimmering ocean, its waves lapping against the shores of countless worlds. Each wave is a universe, each ripple a possibility, and together they form a pattern that is as beautiful as it is infinite. Soothing spin. Feel the delicate balance of existence. As we ponder the fine-tuning of the universe, let the mystery wash over you. Picture the constants of nature as threads in a cosmic tapestry, each one perfectly placed to create a pattern of breathtaking beauty. The universe is not a chaotic void, but a carefully woven masterpiece, its threads of light and shadow intertwined in a dance that has lasted billions of years. Feel the delicate balance of existence, the harmony of forces that allows life to flourish. Let it cradle you, like a gentle hand guiding you through the cosmos. The fine-tuning of the universe is not just a scientific fact. It is a source of wonder, a reminder of the extraordinary complexity and beauty of existence. Interlude prep. As we ponder the fine-tuning of the universe, let your thoughts drift, like stardust carried on the cosmic wind. In a moment, we'll explore another mystery of the universe, the cosmic microwave background anomalies, the echoes of the Big Bang. But for now, let the ambient sounds of the cosmos surround you. Feel the gentle harp, the soft hums of the universe. Let these sounds carry you deeper into relaxation. As we prepare to continue our journey, let us journey back to the very beginning, to the moment when the universe was born. The cosmic microwave background, or CMB, is the oldest light in the universe, a faint glow that fills the cosmos. It is the echo of the Big Bang, a snapshot of the universe when it was just 380,000 years old. And yet, within this ancient light, there are strange patterns, anomalies that hint at mysteries we are only beginning to understand. Imagine, for a moment, the universe as a newborn, taking its first breath. The CMB is that first cry, a whisper from the dawn of time, carrying with it the secrets of the cosmos. But as we listen to this whisper, we hear something unexpected, something strange. Cold spots, alignments, and patterns that defy explanation. What do these anomalies mean? Are they clues to something bigger, something beyond our current understanding? As we explore this mystery, allow yourself to drift into the unknown. Picture the CMB as a cosmic lullaby, its notes echoing across the universe, inviting you to wonder and dream. Let the questions wash over you, not as problems to be solved, but as whispers from the cosmos, inviting you to reflect and imagine. The cosmic microwave background, echo of the Big Bang. The cosmic microwave background is the afterglow of the Big Bang, the moment when the universe transitioned from a hot, dense plasma to a cooler, transparent state. As the universe expanded, this light stretched and cooled until it became the faint microwave radiation we detect today. The CMB is remarkably uniform, a testament to the homogeneity of the early universe. But within this uniformity, there are subtle variations, tiny fluctuations in temperature that correspond to the seeds of galaxies and galaxy clusters. These fluctuations are expected, a natural consequence of the quantum fluctuations that occurred in the early universe. But there are also anomalies, patterns and features that do not fit our current understanding of cosmology. These anomalies are like faint whispers in the cosmic lullaby, hints of something deeper, something we have yet to uncover. As you ponder the CMB, let your mind wander. Imagine the universe as a newborn, its first light spreading across the cosmos, carrying with it the promise of galaxies, stars, and life. The CMB is not just a relic of the past. It is a message from the dawn of time, a reminder of our cosmic origins, mysteries, cold spots, alignments, and clues to something bigger. One of the most intriguing anomalies in the CMB is the so-called cold spot, a region of the sky that is significantly cooler than the surrounding areas. This cold spot is difficult to explain within the standard model of cosmology. Some scientists suggest that it could be evidence of a collision between our universe and another bubble universe in the multiverse. Others propose that it is a statistical fluke, a rare but natural variation in the CMB. But the truth remains unknown, a mystery waiting to be solved. Another anomaly is the alignment of certain features in the CMB, known as the axis of evil. These alignments suggest a preferred direction in the universe, a concept that challenges our understanding of cosmic isotropy, the idea that the universe looks the same in all directions. Could these alignments be evidence of a larger structure, a cosmic fingerprint left by something beyond our current understanding? Or are they simply the result of chance, a quirk of the data? As you consider these anomalies, let them lull you into a state of calm. Imagine the CMB as a cosmic puzzle, its pieces scattered across the sky, waiting to be discovered. The anomalies are not just scientific curiosities. They are invitations to explore, to wonder, to dream. Calming angle. Listen to the universe's first whisper. As we ponder the mysteries of the CMB, let the ancient light of the universe wash over you. Picture the CMB as a cosmic lullaby, its notes echoing across the cosmos, carrying with them the secrets of the Big Bang. Listen to the universe's first whisper, a faint but persistent reminder of our cosmic origins. Let this whisper guide your dreams, like a gentle hand leading you through the cosmos. The anomalies in the CMB are not just scientific puzzles. They are whispers from the dawn of time, hints of something deeper, something beyond our current understanding. They remind us that the universe is full of mysteries, waiting to be uncovered. Interlude prep. As we ponder the mysteries of the cosmic microwave background, let your thoughts drift, like ocean waves carrying stardust across the void. In a moment, we'll explore another mystery of the universe, the shape of the universe, the question of whether it is flat, curved, or something stranger. But for now, let the ambient sounds of the cosmos surround you. Feel the gentle ocean waves, the faint echoes of the universe's first light. Let these sounds carry you deeper into relaxation as we prepare to continue our journey. What does the cosmos look like when viewed from the outside? If such a perspective were even possible. Is the universe flat, like an endless sheet of paper? Is it curved, like the surface of a sphere? Or is it something stranger, something beyond our ability to visualize? These are the questions that guide our exploration of the universe's shape, a mystery that touches the very fabric of reality. Imagine, for a moment, the universe as a vast cosmic tapestry, stretching out in all directions. But what is the nature of this tapestry? Is it flat and infinite, extending forever without end? Or is it finite, folding back on itself in ways we cannot see? The shape of the universe is not just a scientific question. It is a philosophical one, inviting us to reflect on the nature of existence itself. As we explore this mystery, allow yourself to drift into the unknown. Picture the universe as a great, shimmering fabric, its folds and curves hidden from view. Let the questions wash over you, not as problems to be solved, but as whispers from the cosmos, inviting you to wonder and dream. Is the universe flat, curved, or something stranger? The shape of the universe is determined by its geometry, the way space itself is structured. According to Einstein's theory of general relativity, the universe can have three possible shapes: flat, positively curved, or negatively curved. Each of these shapes has profound implications for the nature of reality. A flat universe is one where the rules of Euclidean geometry apply. Parallel lines never meet, and the angles of a triangle add up to 180 degrees. A flat universe is also likely to be infinite, stretching out forever in all directions. This is the simplest and most widely accepted model of the universe, supported by observations of the cosmic microwave background. A positively curved universe, on the other hand, is shaped like a sphere. In this model, parallel lines eventually meet, and the angles of a triangle add up to more than 180 degrees. A positively curved universe would be finite, looping back on itself like the surface of a globe. If you traveled far enough in one direction, you would eventually return to your starting point. A negatively curved universe is shaped like a saddle, with parallel lines diverging and the angles of a triangle adding up to less than 180 degrees. This type of universe would also be infinite, but its geometry would be far more complex, with space stretching and twisting in ways that defy our everyday experience. As you ponder these possibilities, let your mind wander. Imagine the universe as a great, shimmering fabric, its folds and curves hidden from view. The shape of the universe is not just a scientific fact. It is a source of wonder, a reminder of the extraordinary complexity and beauty of existence. Pause for reflection. The ambient sounds grow slightly louder, emphasizing the vastness of the cosmos. Unanswered questions: finite or infinite? Looping? The shape of the universe raises profound questions about its size and structure. Is the universe finite or infinite? If it is finite, does it loop back on itself like a cosmic Mobius strip? Or is it truly infinite, stretching out forever without end? These questions are not just scientific, they are philosophical. They challenge us to think about what it means to exist, to be real. If the universe is finite, what lies beyond its boundaries? If it is infinite, how can we comprehend something that has no end? One possibility is that the universe is finite but unbounded, like the surface of a sphere. In this model, the universe has no edges, no boundaries, but it is not infinite. If you traveled far enough in one direction, you would eventually return to your starting point like a ship sailing around the world. Another possibility is that the universe is infinite, stretching out forever in all directions. In this model, the universe has no boundaries, no edges, and no end. It is a vast, endless expanse, full of wonders we can scarcely imagine. As you consider these possibilities, let them lull you into a state of calm. Imagine the universe as a great, shimmering ocean, its waves lapping against the shores of countless worlds. Each wave is a galaxy, each ripple a star, and together they form a pattern that is as beautiful as it is infinite. Pause for reflection. The ambient sounds shift subtly, with faint, almost musical tones suggesting hidden patterns. Soothing frame. Picture the universe folding around you. As we ponder the shape of the universe, let the mystery wash over you. Picture the universe as a great, shimmering fabric, folding around you like a cosmic blanket. Feel its folds and curves, its hidden patterns and structures. Let it wrap you in, like a gentle hand guiding you through the cosmos. The shape of the universe is not just a scientific fact. It is a source of wonder, a reminder of the extraordinary complexity and beauty of existence. Whether the universe is flat, curved, or something stranger, it is a place of infinite possibility, full of mysteries waiting to be uncovered. Now, let us turn our gaze to one of the most profound and elusive mysteries of the universe, the nature of time itself. Time is the thread that weaves the fabric of our existence, the force that carries us from birth to death, from the past to the future. But what is time truly? Does it have an end, or is it eternal? And if it does end, what does that mean for us, for the universe, for reality itself? Imagine, for a moment, time as a river, flowing endlessly from the past into the future. We are carried along its currents, unable to stop or turn back. But what lies at the end of this river? Does it flow into an ocean of eternity, or does it simply stop? These are the questions that guide our exploration of the end of time, a mystery that touches the very core of our understanding of reality. As we explore this mystery, allow yourself to drift into the unknown. Picture time as a great, shimmering thread, stretching out across the cosmos. Let the questions wash over you, not as problems to be solved, but as whispers from the universe, inviting you to wonder and dream. Does time have an end, or is it eternal? The nature of time is one of the deepest mysteries in science and philosophy. According to our everyday experience, time is linear, moving inexorably from the past to the future. But is this truly the nature of time, or is it merely an illusion, a construct of our minds? One possibility is that time does have an end. In the far future, as the universe continues to expand and cool, all stars will burn out, all matter will decay, and all energy will be evenly distributed. This is the heat death of the universe, a state of maximum entropy where no further change is possible. In this view, time itself may come to an end, as there is no longer any meaningful way to measure its passage. Another possibility is that time is eternal, stretching out infinitely into the past and the future. In this view, the universe is cyclical, going through endless cycles of expansion and contraction. Each cycle begins with a big bang and ends with a big crunch, only to begin again. Time in this model is not linear but circular, a never-ending loop of creation and destruction. As you ponder these possibilities, let your mind wander. Imagine time as a great, shimmering thread, stretching out across the cosmos. Does it have an end, or does it stretch on forever? The answer, for now, remains hidden, a secret held by the universe. Theories: time as illusion, cyclical time. Let's delve deeper into the theories that attempt to explain the nature of time. One of the most radical ideas is that time itself is an illusion, a construct of our minds. In this view, time is not a fundamental aspect of reality, but a way for us to make sense of the world. The past, present, and future are all equally real, existing simultaneously in a timeless, eternal now. This idea is supported by some interpretations of quantum mechanics, which suggests that time may not play a fundamental role in the equations that describe the universe. If time is an illusion, then the end of time is also an illusion, a construct of our limited perspective. In this view, the universe is timeless, a vast, eternal now where everything that has ever happened or will ever happen exists simultaneously. Another theory is that time is cyclical, going through endless cycles of creation and destruction. In this view, the universe is like a great cosmic clock, ticking through endless cycles of expansion and contraction. Each cycle begins with a big bang and ends with a big crunch, only to begin again. Time, in this model, is not linear but circular, a never-ending loop of creation and destruction. As you consider these theories, let them lull you into a state of calm. Imagine time as a great, shimmering thread, stretching out across the cosmos. Whether it is linear or cyclical, finite or infinite, time is a source of wonder, a reminder of the extraordinary complexity and beauty of existence. Calming spin, feel time slowing, stretching, let it dissolve as you drift. As we ponder the end of time, let the mystery wash over you. Picture time as a great, shimmering thread, stretching out across the cosmos. Feel it slowing, stretching, dissolving into the void. Let it carry you, like a gentle current in a vast, dark ocean. The end of time is not something to be feared, but something to be embraced. It is a reminder that all things must come to an end, that even the universe itself is not eternal. And yet, in that end, there is beauty, a strange and haunting beauty that reminds us of the fleeting nature of existence. Let the end of time dissolve as you drift, like a dream upon waking. The universe is not just a place of beginnings and endings. It is a place of infinite possibility, full of mysteries waiting to be uncovered. Interlude prep. As we ponder the end of time, let your thoughts drift, like whispers carried on the cosmic breeze. In a moment, we'll conclude our journey through the mysteries of the universe, reflecting on the secrets we've explored and the wonders we've uncovered. But for now, let the ambient sounds of the cosmos surround you. Feel the gentle echoes, the soft whispers of time itself. Let these sounds carry you deeper into relaxation as we prepare to conclude our journey. And now, as our journey through the mysteries of the universe comes to a close, let us take a moment to reflect on the secrets we've explored together. Over the past 3 hours, we've ventured into the depths of the cosmos, pondering questions that have puzzled humanity for centuries. We've listened to the silence of the Fermi Paradox, wondering if we are alone in the universe. We've traced the invisible web of dark matter, feeling its quiet pull holding galaxies together. We've contemplated the heat death of the universe, the end of time, and the delicate balance that makes life possible. Each mystery has been a thread in the grand tapestry of existence, woven together to create a picture of infinite wonder. These unsolved secrets are not just scientific puzzles. They are invitations to dream, to wonder, to imagine. They remind us that the universe is vast, mysterious, and full of beauty. And while we may not have all the answers, the questions themselves are a gift, a reminder of our place in the cosmos. We are the universe's way of understanding itself, of reflecting on its own existence. And in that reflection, there is meaning, there is wonder, there is peace. As we bring this journey to a close, let these mysteries linger in your mind. Let them drift through your thoughts like stardust carried on the cosmic wind. Perhaps they will guide you into dreams, where the boundaries of reality blur and the impossible becomes possible. Or perhaps they will fade into the void, leaving you in a state of quiet, restful stillness. Either way, let them carry you into a deep and peaceful sleep. The universe is vast, and its secrets are many. But for tonight, we've explored enough. We've wondered enough. Now it's time to rest. Let the mysteries of the cosmos cradle you, like a gentle hand guiding you into the void. Feel the weight of the universe's questions dissolve, replaced by a sense of calm, of stillness, of peace. Sleep well, knowing that the universe keeps its secrets for another night. And when you wake, the mysteries will still be there, waiting for you to explore them once more. But for now, let go. Drift into the void, where time slows, where thoughts fade, and where the universe whispers its secrets in dreams. Good night.